Hello, my name is Aaron Yetton, and I will be presenting for ESI 6891 IEMS Research Methods. The journal article Body Mass Penalties in the Physical Fitness Test of the Army, Air Force, and Navy, written by Vanderberg and Crowder in the Journal of Military. Our growing softness, our increasing lack of physical fitness is a menace to our security. John F. Kennedy. The military requires its personnel to partake in 2 physical readiness tests per year, or PRTs. There's very few exceptions to this, including medical waivers. The scores are evaluated using simple tests such as push-ups, sit-ups, and a time distance run. These tests were developed years and years ago and haven't changed very much, although the demographics of the military have changed considerably, especially when speaking about the increase in the female population within the branches. Recent research has identified empirical physiological bias towards heavier members. We're not necessarily talking about body fatness here. We're talking about biological scaling models that are based on the study of allometry, the study of growth of a part of an organism relative to the growth of the whole. So this research paper theoretically quantifies that bias within the physical readiness testing towards heavier males and females, and it also offers 2 corrective methods to eliminate and mitigate this. Promotion within the military is highly competitive, and part of the evaluation factor is the physical readiness testing. You can see how this is significant to any military personnel that has to perform this test. Also, this can affect the retention of the individual member. Using hypothetical cases, the authors have quantified 60 versus 90 kilogram man and a 45 versus 75 kilogram person to have a 15 to 20% bias in the raw scores of fitness, in the physical readiness test scores. This is certainly significant. Better test methods could also enhance the military's physical fitness program overall, and more accurate non-biased tests would mimic the occupational relevance, which would enhance testing actual ability to complete military occupational duty. We know that each of the services require members to perform push-ups, sit-ups, and a timed run as part of their physical readiness test. We also know that these particular exercises tend to be biased towards heavier individuals. Let's consider the 1RM test, or the 1 repetition maximum weight test. Think of it as a max bench lift test. Larger individuals generally have more muscle mass, which means they would do better in this test. This holds true. Well, the opposite bias occurs with repetition-based endurance testing. So for sit-ups, push-ups, and also time run, we're looking at a bias towards heavier individuals. So in exercise science, allometry can be used to understand how certain outcome variables of physical performance relate to 1, 2, or even 3 dimensions of factors such as height, cross-sectional area, and mass. Allometric relationships states that an outcome variable y is related to a dimensional variable x, as demonstrated in the equation shown here, y minus bx raised to the a. We can use these equations to better understand and evaluate the bias within testing, as well as use them as correction factors down the road. You can see here as an example of negative allometry how the baby's head grows slower relative to the torso of a full-grown person. Here's an example of positive allometry, where fiddler crab's claw grows greater in proportion to the rest of the body. The objectives of this research were to quantify the penalty being assessed to the current physical readiness test methods. We know that there's bias, but how much bias is there? Other objectives included offering 2 different methods that could be used to mitigate the bias going forward. This would include implementation of a revised fitness test with balanced events, which we'll talk about later, and development of correction factors that can be used to adjust raw scores. We can see that the occupational relevance for the fitness test is not necessarily in line with what most physical military tasks are. Push-ups, sit-ups, and distance by body weight resistance do not correlate with heavy load carriage and lifting heavy equipment and supplies, which most physical military tasks are. We can use allometry to understand how certain outcome variables of physical performance are related to one another. We can use these allometric relationships to derive equations to better understand the bias within certain exercises. In fact, these equations have already been derived in past research and validated. We know that the equation for the 1Rm is proportional to mass raised to the 2/3. So what we're saying is as mass increases, strength increases, but not in direct proportion. Let's think of it another way. A 20% heavier exact scale model of a person could not necessarily lift 20% more weight. Using the equation above, it's more like 13% more. These allometric equations exist for a multitude of different tasks and exercises and have been used throughout the years and validated. As you can see, we changed the 1Rm times mass raised to negative 2/3. We changed the equation to 1Rm times mass raised to negative 2/3 for a negative correction factor. That is, for when individual masses increase pertaining to a maximum bench press, there's a penalty imposed on a heavier person due to. These allometric equations have been extended on this slide to show the equations for endurance-based exercise, which equals repetitions times mass raised to the 1/3. Additionally, the allometric equation for VO2 max on aerobic capacity is equal to times mass raised to the negative 1/3. Using the equations outlined prior and plugging in an average age military demographic, 28-year-old male, as discussed, 60 kilogram versus 90, and a female of 45 versus 75 kilogram, the authors have built the following table. We can see for the Army, the event for push-ups, sit-ups, and 2-mile run for a 60 kilogram male, the maximum performance is 77 push-ups, 82 sit-ups, and a run time of 13 minutes and 18 seconds. These all equate to a score of 100. For a person of 90 kilograms, using the allometric equations to do the same amount of work, would have to do 67 push-ups, 72 sit-ups, and have a run time of 15 minutes and 14 seconds. Although this person would not receive hundreds, but an 89, 89, and 78, equating to a score of 256. The difference is 14.7%. We can see that the authors have calculated this across the board for each experiment with a maximum difference of 20% in a female of 75 kilograms versus a female of 45 kilograms for the Navy. The authors have theoretically quantified a 14.7 to 20% bias within physical readiness testing in the military. This is quite significant. So how do we mitigate these factors? Many people have suggested implementing a load carriage type test, such as a 50 to 100 pound rucksack. This wouldn't quite necessarily eliminate bias, as it involves carrying your own body mass, which brings back full circle to the bias anyways. And also, a great amount of empirical evidence exists that shows the ability to carry weight does not increase with proportion to body mass. So the authors suggest an alternative is to balance a biased lower body mass event with a heavier mass test. For example, do a fixed weight bench press test of how many times you can repetitively bench a certain weight. This would be biased towards heavier individuals and balance out the test for the other repetitive endurance tests such as sit-ups and push-ups. Also, the authors suggest using the allometric equations to come up with simple coefficients that can use to multiply the raw scores and essentially reduce or increase scores dependent on which exercise is being performed. These would simply adjust the scaling factors and bring everything back into equilibrium. Discussion. This research paper theoretically identified and quantified bias within PRT testing in the military. The bias ranged from 14.7 to 20%, depending on the weight of the member. The author identified two separate methods which would mitigate the bias moving forward, balancing one bias event for a lighter member with another bias event for a heavier member. Number two would be using simple correction factors to adjust raw scores of PRT events. Future research can be done with actual service members performing testing instead of theoretical members, and also determine how to balance PRT events with bias events on each side of the body mass spectrum. Future research can also be done to develop new PRT events that do not include body mass and simple to perform and evaluate. Please email any questions to aaron.yedden@knights.ucf.edu. Thank you.